today's lesson, what we're going to do is talk about isosceles triangles. And you know that by definition of isosceles, you have two sides being the same. So one of the theorems that we're going to talk about is if you have an isosceles triangle, then you know, or if you have a triangle, then you've got angles which are opposite congruent sides. They have to be congruent. Also, if you have a triangle and you know that you've got congruent angles in it, then you're going to say sides opposite congruent angles are congruent. So these are theorems that all play out the isosceles triangle. And then you also know as well that base angles of an isosceles triangle are congruent. We'll use these theorems a lot in proofs, and the key part is the fact that you have to be in one single triangle where you've got two sides the same and the angles opposite them are congruent, or one single triangle where you've got, I forget what I just said, but if the angles are, if the sides are the same, the angles opposite them are congruent, and vice versa. So there's this corollary, which is just a thing that, it's a theorem that's proved by other theorems. I wouldn't worry so much about the word corollary, but just understand that if you have an isosceles triangle, then the bisector of the vertex angle also acts as the median and as the altitude to the base. And all of these converses would be the same as well. So what they're saying essentially is if you have triangle ABC and you know that AC and BC are congruent, if you happen to have the angle bisector of the vertex angle, then that segment that goes from vertex C to the opposite side, we'll call this opposite side at this point D, this angle bisector acts as the median as well as the altitude. So in any isosceles triangle, the median is also the altitude, is also the angle bisector. I should probably give these 2 marks. Lots of algebra can be done with isosceles triangles. Here's one part of it. Here you're trying to solve for x. Well, in a triangle, if two sides are the same, the angles opposite them must be the same. So you've got the equation 4x minus 20 equals 40. Subtract 20 from both sides. 4x is 20. Divide both sides by 4. X equals 5. And all that it asked you to do was solve for x. On this next triangle, I want you to find the degree measure of each angle. Well, you've got DE and FE are congruent, so the angles opposite them are congruent, which means that if F is x plus 8, D is also x plus 8. Because the three angles of a triangle add to 180, then if I combine all my like terms, I get 4x's plus 12 equal to 180. Again, you're combining all the like terms around the triangle, subtract 12 on both sides, and then you get 4x to be 168. Divide both sides by 4, and x is 42. Well, this asked you to find the measure of each angle, not just find x. So if that's the case, then you're going to say here that angle D is going to be 42 plus 8, which is 50 degrees. Angle E, let me go to angle F for a second. Angle F is also 42 plus 8, which is 50. Angle E, which is the vertex angle, is twice 42 minus 4, and that ends up giving you 80 degrees. So algebra, we can get all the way around the angles of the triangle. It tells you here that angle B and angle C are congruent. So you know that these guys are congruent. So in a triangle, if two angles are congruent, the sides opposite them are congruent. Therefore, you can have an equation that says 2x plus 10 equals 5x minus 20 using the distributive property. If you subtract 2x from both sides, 10 equals 3x minus 20. Add 20 to both sides. 30 equals 3x. And then 10 is equal to x. It wants you then to find the length of each side. So we know that AB, by the way, which happens to be the same as AC, when you plug in the 10, it's going to be 2 times 10 or 20 plus 10, which is 30. So those both have the same measure. And then BC, 4 times 10 minus 3 is 37. So there's all the algebra. We can put in factoring, which you'll see on the homework, and then maybe some other algebraic problems with fractions. Let's talk about some proofs. So on this particular proof, we've got AB being congruent to CB, and you've got AD being congruent to CE. They want you to prove that BDE is isosceles. The only way we can do that is to get into that triangle there, and here's probably the best way to go. Whoopsie, let's try that again. Let's see. Let's try this again. This is going to be statements, this is going to be reasons. We're going to put these on the same line. AB is congruent to CB, and AD is congruent to CE, and that's given to you. We've already marked it off. And then what we can say is angle A is congruent to angle C. Let me try and get this back on the picture there a little bit better. Okay. The reason why we know that these two angles are congruent is because in triangle ABC, then angles opposite congruent sides are congruent. That's that one theorem that we talked about earlier. Once we have that, we have enough information to prove the smaller triangles on the outside. So number 3, you could say then triangle BAD is congruent to triangle BCE, and that is because you've got side angle side. After that, you can now get into those yellow sides marked on the triangle where you say BD is congruent to BE, and that's by CPCTC. Corresponding parts of congruent triangles are congruent. And the fact that you have two sides marked the same, you've got a you've got an isosceles triangle. So now you can say triangle BDE is isosceles because in an isosceles triangle, two sides are congruent. There are two congruent sides. Okay, so hopefully that is good for your first proof. Second proof is similar in terms of isosceles triangles. Let's see what we got here. Statements, reasons. We'll put everything all on one line again. So AB is congruent to AC. BD is congruent to CF. DE is perpendicular to BC. FG is perpendicular to BC. So AB, by the way, this up here, I think your notes might be a little bit different. That's supposed to be A. So you've got AB, which is this whole side right here, is congruent to this whole side right here. Those guys are the same. BD, part of that side, is congruent to the other part of that side. And then you have the perpendicular segments, which give you right angles. And while it's true that all 4 of these are right, the only angles that we need are the ones inside those small triangles. So all that we really need to talk about in our proof is how this angle and this angle are right. So I forgot to write given here. There we go. Number 2, 3 letters, angle DEB is congruent to angle FGC, and this reason is perpendicular lines form congruent right angles. So we got that going on. Then at that point, we can go back to the fact that we have a big isosceles triangle in which these guys right here are congruent. So that would be angle B is congruent to angle C. because in triangle ABC, angles opposite congruent sides are congruent. Now we've got those small triangles congruent because of AAS, and then we're going to go for a CPCTC. So I'm going to bring this up a little bit. Number 4, we know that triangle DEB is congruent to triangle FGC, and we know the reason here is because of AAS. And then we have BE is congruent to CG because of those famous 5 letters, CPCTC. All right, so that should be good.